In today's video, we're going to be going through a worksheet aimed at those students that are targeting a grade 6 to 9 in GCSE Maths. The first question is a simultaneous equations question. The equations are 3x plus 2y is equal to 16 and 4x minus y is equal to 9. So we want to eliminate either x or y in one of these equations so that we can find a value for either x or y. And the simplest way to do that is to make the y's or the x's cancel out. In order to get this, because we don't have it right now, we'd have to multiply the second term by 2. And if we do that, our y's would both be 2y. So if we do that, our new simultaneous equations would be 3x plus 2y equals 16 and 8x minus 2y is equal to 18. And we can see that we have plus 2y and negative 2y. If we want to get these to equal to 0 or to cancel out, we'd have to add everything. So if we did that to this equation, we'd get 11x, these cancel out, is equal to 34. We have 11x equals 34, which is x equals 34 over 11. And to find the y value, we just substitute this into one of our equations. So if we substituted this x value into our first equation, we'd get 3 lots of 34 over 11 plus 2y is equal to 16. If we multiply this, we'd get 102 over 11 plus 2y is equal to 16. To get the y on its own, we'd have 2y equals 16 minus 102 over 11. To get y on its own, we can just divide that by 2, so we get y is equal to 8 minus 51 over 11, which would give us y is equal to 37 over 11. If we wanted to double check our answers, we could just sub in the x and y values into our second equation and make sure that it's still correct. Question 2 tells us to factorize and solve the equation x squared minus 5x plus 6 equals 0. So to factorize this, we take these into two different factors. We know that since we have x squared at the beginning, both of our terms will just start with x, and remember, the coefficient of x will be the sum of our two numbers, and this last number 6 would be if you multiplied our two numbers. So we need two numbers that multiply to give us 6 and add together to give us minus 5. We could use x minus 3 and x minus 2 for this, as minus 3 multiplied by minus 2 gives us 6, and minus 3 plus minus 2 gives us minus 5. And now we're not done yet. We factorized it, but we're also told to solve it. And we know that each of these is equal to 0. So x minus 3 is equal to 0 and x minus 2 is equal to 0. We can just do rearranging to get x equals 3 and x equals 2. So we've solved and factorized this equation. Question 3 tells us to expand and simplify 2x minus 3 and x plus 4. So the way I like to do it, a simple way for me to remember how to do it, is I use FOIL to remember how to expand two brackets. So you do the first in each bracket, the outside in each bracket, the inside terms of each, and we would do the last terms of each bracket. So if we apply that to the two brackets, we have 2x minus 3 and x plus 4. Multiplying our first terms would give us 2x squared. Our outside terms would give us 8x minus 3 multiplied by x would give us minus 3x, and minus 3 times 4 would give us minus 12. We can see that 8x and minus 3x are like terms, so we can just subtract minus 3 from 8 to give us 2x squared plus 5x minus 12 as the fully expanded and simplified term of this equation. Question 4 tells us to rationalize the denominator in the term 5 over 2 plus root 3. And when rationalizing the denominator, we want to make the denominator a rational number, so ideally no surds or anything like that. So what we do is we flip the sign that is in the denominator, so this will now become 2 minus root 3, and we multiply this by the top and the bottom, the numerator and the denominator, because obviously if you do something to the numerator, you also have to do the denominator, and the other way around. So if we do this one term at a time, so if we had 5 multiplied by 2 minus root 3, we'd get 10 minus 5 root 3. And if we did 2 plus root 3 multiplied by 2 minus root 3, we'd get 2 times 2 is 4 outside, minus 2 root 3 inside, plus 2 root 3, and root 3 multiplied by negative root 3 is negative root 9, which is just negative 3. We can see that our minus 2 root 3 and our plus 2 root 3 cancel out, which would leave us 4 minus 3, which is just the same as 1. So then our final term would be 10 minus 5 root 3 on the numerator and 1 as the denominator, and obviously anything divided by 1 is just that number itself, so we could just write 10 minus 5 root 3, and then we've rationalized the denominator. Question 5 is an inequality question. The inequality is 2x minus 3 is less than 7. We want x on its own for this inequality, so first of all we can add 3 to both sides, which would give us 2x is less than 10. And if we divide both sides by 2, we'd see that x is less than 5, and that's the inequality solved. Question 6 tells us to find the gradient and y-intercept of the equation 3x plus 2y is equal to 12. Well, we know that the easiest way to see the gradient and the y-intercept of an equation is to put it in the form y equals mx plus c. So let's try get our 3x plus 2y equals 12 into this form. So we have 3x plus 2y equals 12. We want y on the left and x on the right, so we get 2y is equal to minus 3x plus 12. All we did was just subtract 3x from both sides. And then we want y on its own, because that's how it is in the form of the question. So divide everything through by 2 to give us y is equal to minus 3 over 2x plus 6. And if we compare this to our form y equals mx plus c, the c is 6, so we know that 6 is our y-intercept. And the m is our gradient, which here we can see is minus 3 over 2. So we can say that m is equal to minus 3 over 2. M is just the gradient. Question 7 tells us to solve sine x is equal to 0.5 in the interval between 0 degrees x is less than 360 degrees. Well, to do this, we'd have to do the inverse of sine, or sine to the minus 1 of 0.5 to get x, our first x value, which would just give us 30 degrees. And when finding the next sine value, you do 180 minus our first sine value, which is 30 in this case, and that would give us 150 degrees. Those are our two values within this interval. For question 8, we're told to calculate the volume of a frustum given this radius and its height. So what we do for this is we'd get the volume of the entire cone, which is given by 1 over 3 pi r squared multiplied by h, and we'd subtract the volume of the smaller cone that we're given, which we'd also work out with 1 over 3 pi r squared times h. So for the big cone, our radius would be given by this distance, and we'd square that, and the height would be this vertical distance. And for the smaller cone, our radius would just be this distance, and the height would just be this. So once you work out the volume of the cone at the top using this formula, we can just subtract that from the volume of the entire cone, and that will give us the frustum, which will be shaped like this. Question 9 tells us to use trigonometry or the sine rule to work out this missing length b, and we know that the sine rule is a over sine a is equal to b over sine b. So let's start by substituting what we know into this. So a is the length opposite the angle a, which is 40 here, so small a would be 7 over, and sine a is just going to be sine of 40 degrees, as this is, we're given that here, and that is equal to b, which is the missing length, so we don't know that yet, we'll just leave that as b for now, over sine 60 degrees, we're given that here. So if you want b on its own, we'd have to multiply both sides by sine 60, which would give us 7 sine 60 over sine 40 is equal to b. And if you put this into a calculator, we'd see that b is equal to 9.43107, and then there's more numbers after that, but we can just round this to 9.43 centimeters, and that is the value of length b. Question 10 asks us to prove algebraically that the sum of two odd numbers is always even. So first we need to show that we are representing two odd numbers that apply for all odd numbers. So our first odd number could be 2n plus 1, for example. So the reason we use 2n plus 1 is we don't know what n is. N could be odd itself. So say n was 3, n plus 1 would be 4, and that's not odd anymore. So by doing 2n plus 1, we make sure that 2n is obviously even because we can divide that by 2, and then adding 1 to it makes it odd. And to show any other odd number, to represent any other odd number, we can use 2m plus 1. It doesn't really matter which letters you use, it's just to show that they're two different numbers. And we're told to prove that the sum of these numbers is always even. So that just means to add them together. So if we did 2n plus 1 plus 2m plus 1, we'd just get 2n plus 2m plus 2, which is the sum of our two odd numbers. And since we can take a factor of 2 out of here to give us n plus m plus 1 multiplied by 2, we can say that this is divisible by 2 and therefore must be even. So if we were to write that out, we could write factor of 2 can be taken out from the sum of two odd numbers, therefore must be even. And that is how we would prove this algebraically. Thank you guys for watching this video. I hope you found it useful. Leave a comment below letting us know what sort of topics or what kind of videos you want us to make in the future.